Welcome to Campus. Welcome to Campus. Welcome to Campus. Today we have decided to look at rates of reaction. We want you to understand the collision theory. What happens when reactions take place? Now imagine if you had a pot and you were trying to cook some meat, right? If you put this meat in the pot here, this meat in the pot here, right, the water in the pot are only going to collide with the meat on the surface of this big piece of meat. How can we make this reaction faster? Think about it. How can we make this reaction faster? Okay, what we got to do is we can cut up the meat, and by cutting up the meat, we are actually increasing the surface area. It means whatever water particles we have in there are going to collide with more meat particles. Now, this is not only about meat. If you are reacting calcium carbonate, if you take bigger pieces of calcium carbonate, and if you take calcium carbonate powder, the powder is going to give you a faster reaction. By breaking up this meat into smaller pieces like that, we are increasing the surface area. Now, what are the factors that affect the rate of reaction? We are now looking at surface area. When you break up big pieces into smaller pieces, you are increasing the surface area. Another factor that we might want to look at is temperature. If I am cooking the meat, if I increase the temperature, that's why we increase the temperature when cooking. What happens is, if we increase the temperature, the water particles in the pot will gain more energy, and their chances of colliding with meat particles is greater. The frequency of collisions become greater. It is always about collisions, right? The next thing that we want to look at is concentration. If I'm reacting those two reactants, you can see we've got 3 particles of each. If I increase the concentration, then that means that there will be a higher frequency of collision and your reaction will happen faster. And the last one we want to look at today is pressure. If I'm having a container like that and I'm having those particles in there, if I increase the pressure, that's going to result in the particles getting closer together. When you increase the pressure, you reduce the volume. Now, the rate of reaction depends on, 1, the frequency of collisions. The greater the surface area, the more the collisions. The higher the temperature, the greater the energy, and the more the collisions. 2, the energy of the particles, which is the temperature which we've spoken about. And also, there is a certain minimum amount of energy that is required for a reaction to take place. What is it? Activation energy. Thank you very much.